clienții cât mai mult. Subiectul pe care eu, alături de Pavel Covaneț, vrem să-l atacăm astăzi este cel de business continuity. Ce putem să facem în astfel de situații cu soluțiile Aruba Networks, astfel încât să oferim clienților noștri cea mai bună oportunitate, astfel încât businessul lor să funcționeze în continuare. Mă bucur foarte tare că l-am pe Pavel alături. El este Senior Sales Engineer pe toate soluțiile Aruba Networks, pe toată Europa. Este, sincer pot să spun cu mâna pe inimă, cel mai bun inginer pe care îl are Aruba în Europa. Și mă bucur foarte mult pentru că el va povesti un pic în mai mult detaliu decât mine aceste soluții. Situația în care ne aflăm acum este inedită pentru toată lumea și ce cred eu că este cel mai important acum este să înțelegem care exact sunt opțiunile pentru toți clienții noștri și să transmitem informațiile cât se poate de clar mai departe, astfel încât aceștia să înțeleagă ce este posibil pentru ei. Și dacă în această perioadă, din diverse motive, nu pot să implementeze planurile de care ar avea nevoie, astfel încât businessul lor să continue să funcționeze cum trebuie, măcar să avem pe viitor această experiență în spate și să ne gândim mult mai bine cum tratăm lucrurile. De asemenea, cel mai probabil, chiar dacă carantina se va termina într-o lună jumate, două, va continua o perioadă cel puțin la fel de dificilă, cu restricții de trafic, restricții de disponibilitate la locul de muncă, astfel încât e important să ne gândim la ce măsuri putem să luăm deja pentru acea perioadă. Soluțiile Aruba Networks pentru business continuity se bazează pe două tehnologii principale, tehnologia de Remote Access Point și VIA, care vine de la Virtual Internet Access, este soluția de VPN a Aruba Networks. Ambele soluții sunt gândite să funcționeze cu controllerul Aruba și sunt cel mai bine pregătite pentru clienți care au deja un controller Aruba în infrastructura lor. Acum o să rog pe Pavel să vorbească un pic mai mult despre exact soluții în sine, cum putem să le implementăm, care sunt opțiunile și, cel mai important lucru, faptul că Remote Access Point-urile nu sunt o serie în sine de puncte de acces, ci mai degrabă orice AP Aruba poate să devină Remote Access Point. Pavel, that was me, so if you want to take over, just feel free.
Yes, please. Thank you very much for the intro. Let me try to share my screen. I hope it works. Do you see my screen, please?
Yeah, we're all good.
Okay, perfect. So good morning, everyone. Or yeah, we're pretty close to actually good afternoon. Thank you very much for coming. I didn't really expect this many participants to be in the call. So thank you very much for being here, for your time. And unfortunately, believe me, I tried over a couple of years. I did really try to learn a little bit of Romanian, but no, for me, it's pretty close to impossible. So I will have to stick to English. I hope you don't mind. Please, I believe that you can ask questions even during the presentation. So if that should be the case, please go ahead and ask. Otherwise, it's going to be a boring 45 minutes with me. But anyway, so I believe everyone really knows what this is all about. It is more about remote access than ever before. And this is something we were always somehow having in our portfolio, but we were not really always emphasizing on this because we never really believed that something like this could really hit us this bad. So currently, you know, you getting your stuff really is the most important part of your entire day, because otherwise you're not able to work. And since everyone now is stuck at home in your home offices, getting your stuff, having access to your files, to your network resources, which are locked down back in your office, is more than crucial, or is more crucial than ever. So this is really, really important. And ever since Aruba Networks, for those of you who actually know Aruba Networks or who knew Aruba Networks before we got acquired by HP, you probably know that we always used to have a motto, and the motto was, people move, networks must follow. And this is probably, currently people say that, we are not really moving, but yes, actually we are. We moved away from the known, away from our networks, from our office space where everything is known and everything is trusted, into a new world that is not necessarily to be considered as untrusted, but it is a new network. It is a new environment. It is an environment that is completely sealed off of your printers, your data stores, your repositories. I mean, pretty much all what you were experiencing so far is locked out. And now you have to somehow access it. And you have to access it with your mobile devices. You have to access it with your laptops, with your big PCs, maybe even with servers. Some of you might have a little lab at home, and you never know. So, there's different scenarios as these are trying to somehow get online. This is exactly what we were always addressing. And for those of you who saw my presentation before, somewhere in the past, you've probably seen this slide previously. And when you take a very, very close look at this slide on the bottom line, just between Wi-Fi BLE tags and wired access, you will see a category that is called remote access. And there is a little pictogram of a small remote access point and a fancy logo saying VIA, which is the logo of our VIA client. And this is exactly the niche I'm going to be talking about. This is exactly how this perfectly blends into what we already have. And believe it or not, the remote access point is pretty old. The remote access point, the concept of a remote access point giving you native remote access into your network, is actually dating back to 2004. So in 2004, we already had the remote access point, and originally, believe it or not, we actually did it for Microsoft. It was a closed project for a company everyone pretty much knows, Microsoft, and they actually developed this, or they had us develop this for their traveling people, for their teleworkers. And back then, roaming costs were actually the ones they were trying to eliminate by having native access, because back then 1 minute was pretty much $10 to $15. So they needed some kind of access method how they could not use GSM, but use Wi-Fi or use, let's say, voice over WLAN in order to make, let's call them, cheap calls. And for that, since quite a lot of different mobile devices, even back then, were not able to accommodate a VPN client, they needed native access. So they needed something that would be the middleman between their trusted network and the environment they currently were in, without cables attached and without any kind of virtual interfaces, compatibility issues, dial-up VPN clients that had to be pre-installed, pre-staged, configured, and things like that. And this is how the native remote access in form of a remote access point got born. And we liked it pretty much, so we made a fully blown product out of it. And back in 2000, I believe it was 4 or 5, it really became a rock solid part of our product portfolio. And this is exactly what we're going to be talking about today. So what does it consist of? So first of all, if you happen to have your Aruba infrastructure, we're not touching it. We're only adding something new to it, but we're not touching it. That means we don't care what you have. You can have your Wi-Fi system maybe implemented. You can have your ClearPass for centralized authentication authorization. You can have your airwave management for centralized log and alerting and reporting and management. You can have all the policies configured on your mobility controller, as I said before, if you happen to have an Aruba, if you happen to be an Aruba customer. But if you're not, that doesn't really matter, because the mobility controller is actually all you really need to be in your data center, to be in your office. And what is really nice, the only two things we have to really add, should you be already an Aruba customer, is the remote access points, or if you happen to be alone, or if you happen to be connecting individual devices, which, for example, do not feature all the connectivity possibilities, or you simply wish not to use a remote access point, you can have the already mentioned VIA client, which installs on individual systems, which we call on the road, but can be also individually used wherever. It doesn't really matter where exactly you are. Now, taking it back to the remote access point, When we're talking about a remote access point, we are talking about two models which are sort of dedicated to be remote access point platforms. The first platform is the AP303H, H originally standing for hospitality because it was hotel chains for whom we developed this series for. And originally it was meant to be covering the two worlds, as we call them, the wired world and the wireless world, because in a typical hotel room, in a guest room, you have both worlds coming together because you have the Wi-Fi that is required by guests. You have, of course, the set-top box, which has an RJ45 typically. You have the Mighty Fridge. I call it Mighty Fridge because it builds everything automatically. It puts it onto your room bill as soon as you take something out of it. That typically features a little computer, Raspberry Pi or something, that is connecting to a wire, of course. Then you might have a desk phone, which is voice over IP, but still needs a cable. So from this, we just swapped it over into remote access, and we said, well, if we can do it in a hotel room, we can do it in your home office too. So we can actually not having you have one AP and one switch in order to accommodate wired and wireless clients, but we can actually, zap two flies with a single zapper by simply having one AP that has two radios built in, 2.4 and 5 gig, the usual thing, and then plus have those 4 additional Ethernet interfaces on the bottom side, the one with the red label even featuring PoE out, so you can power something like a desk phone or something that needs power right off the AP without the need of an additional power supply. Now, of course, there's also the possibility, the little rectangular gap on the side you see is a USB interface, so you can attach directly a 3G, 4G modem in order to utilize carrier data or to have carrier data access directly off the remote access point. There's also another version to this, which is the 203R or RP, RP standing for remote power. Yet again, this time it is a yellow label being on one of the interfaces on the backside. And that actually marks this interface as being PoE out, capable in the RP version. Long story short, again, it is the same concept, this time with 3 interfaces. One very interesting thing about this model is that it features a built-in power supply. So you no longer need a power brick externally, but you simply get grid power and put it directly onto the AP, onto this AC terminal. You just simply attach a 2-line power cord directly to the AP, and the 220 volts coming off the public power grid will be transformed directly in the AP, so you no longer need any external power supplies. Behind that rectangular blind on the top, the black one, sits another USB interface for 3G, 4G connectivity. And now, some of you might ask, well, this is really cool, but you only have 2 APs. Is that it? Seriously? Well, it's not, because as a matter of fact, when you take a look at all of our APs, what is very important to remember is that all of our APs can work as remote access points. And I really mean it, all of them. That means the newest 500 series supporting 11AX, the 300 series supporting 11AC, even the predecessors, which I no longer have on this slide, like the 200 series and the 100 series, and even the two-digit APs, all of them are capable to be provisioned or, let's say, configured as remote access points. Not only those two I talked about in a greater detail, but the outdoor ones as well, the rocket ones as well. So this is really sweet. So it doesn't really matter whether you have an instant access point, whether you have something we call a campus connected AP that needs to hook up to a physical controller or to a virtualized controller in order to work. All of these APs, every single hardware we have, access point hardware, can be configured as a remote access point. Well, what sits on the other side, I already mentioned to you previously that you have to have a controller. Yet again, there are no, I would say, preferences or no special requirements for the controller. It just needs to be a controller. It can be a stack, can be a standalone controller, and it can be any model. The only difference is, yet again, the performance. How many access points can be terminating, how many VPN tunnels can be terminating, how many users can be using that infrastructure. But as a matter of fact, you can actually mix and match every single model with every single model. It doesn't really matter as long as you have a controller. So you can have a 7005 as good as a 9004. It doesn't really matter. All the features will be available on every single platform, right? So again, we do not force you into a specific model which would only support all the features, but these features are supported throughout the portfolio. Now, how does it work in a greater detail? Well, first of all, we got the remote access point on one side and we got the controller on the other. When we configure the access point to be a remote access point, we actually promote it a little bit, because you probably remember me telling you that if you have a controller-driven network, that means in the center of the heart sits a mobility controller, that the Wi-Fi access points would be, excuse my language, stupid. That means they can be considered, considered, our development and our engineers hate it when I say this, but let me try. They can be compared to RF transceivers. So there are two radios inside. They just simply take whatever they can see in the air, they transform it into electrical signals, they shoot it into the Ethernet cable, and that's it. Now here we take it to the next level, so to say, because we do need some firewalling on site. So what we do, we have a very, very strong cryptographic core. We have a very, very strong CPU in pretty much every single AP we have. And this is what we utilize. So we actually configure the AP to run a policy enforcement firewall engine right on its platform. So you have routing, you have local routing now with the AP. So you no longer have to tunnel everything back to the controller, but you can actually process data where it happens. So you can process data at the AP in your home office. So you got your Ethernets, your USBs, you got all, the radios and everything, and then you have the cryptographic core in the AP, and you have the policy enforcement firewall with the routing engine, with DPI, with layer 7 awareness, and all those different features I will be talking about in a sec. And then on the other side, you have yet again another policy enforcement firewall center or engine running in the controller. That means securing the network from the other side. You have your APIs, you have your policies, you have your authentication engine, you have your VPN services. I mean, pretty much all the features you used to have from a mobility controller, should you already be in possession of one. Now, what is very important, when we have the remote access point, there are several ways how this access point can work. Now, first of all, we need a handshake. We need a tunnel to be established between the remote access point and the mobility controller. So here in this schematics, we got the remote access point representing by that wrap. We got your home router, which could be a DSL or cable or FTTH or whatever you might have at home, Eurodoxes maybe. The very important part is that we have an RG45 cable in our hand. Then we have the turquoise cloud representing the public internet. And then on the other side, we have your data center. We have your office. That means you have all your servers, you have your maybe firewalls, your PBXs, whatever you have in your office network. Plus, you have your mobility controller. Now, what happens next is that every single AP we have, not only those two I mentioned to you in a greater detail, but all of them, all of the APs we have, feature something we call TPM. It's a so-called trusted platform module. And the TPM holds a certificate. Now, this certificate is being implemented into the TPM in the factory while the AP is being produced. So every single AP has a certificate. And this certificate will be used by the AP to actually authenticate itself towards the mobility controller before the mobility controller lets it establish an IPsec tunnel. This is for pure security reasons. And the reason behind it is that if you, let's say, should lose your remote access point, you should, maybe it will get stolen or something bad will happen to it. Well, you can do the same you would do if you would lose your mobile phone. You would call your carrier and you would let your SIM card to get blocked, to be blocked. You would block your SIM card. And this is exactly what can happen here. If, for example, your remote access point is broken or gets stolen or you simply lose it, you can call the network administrator and you can tell him to actually take it off the whitelist. And that is exactly what would happen if a carrier would block your SIM card. Your phone would no longer work. Hence, in this world, the remote access point will no longer be able to connect to your corporate network. Now, after this authentication has passed and after it had been, legitimized and after the remote access point had been checked that it is on the whitelist and it is entitled to establish that IPsec tunnel, it will use another certificate, yet again stored in the TPM module, to establish that certificate-based IPsec tunnel between itself and the mobility controller. Now, when this happens, the mobility controller pushes the entire configuration onto the remote access point, and this is the point where the remote access point gets its configuration. As soon as you turn it off, it loses the configuration deliberately, so that, if someone would steal it and take it apart, there would be nothing that could compromise your network. So this is it. Now, there are 3 operating modes, and what is very important to realize is it doesn't really matter whether we're talking about a Wi-Fi radio or whether we're talking about the wired interface. these free operating modes I'm just about to talk about these are available on actually both the wired and the wireless. It doesn't matter. So the first operating mode is something we call full tunnel. Now the full tunnel means whatever goes into this interface or whatever goes into this SSID will be tunneled to the other side, to the mobility controller. One of the possibilities is maybe use it for voice or for something where you are 100% sure that you need to tunnel it back to the corporate network for, let's say, security reasons or for backdoor elimination or whatever. Doesn't necessarily have to be voice. Another possibility is to have split tunnel. Now, when you have split tunnel, you have the possibility to utilize the built-in firewall, which actually runs in your remote access point. And the built-in firewall can determine which data needs to go back to the data center, that means back to your company, and which data can or has to stay local. So for example, when you do local printing, it would be completely useless to tunnel that data back to your company and then back to your home office, because you would just simply, exhaust the internet lines unnecessarily. And secondly, the printer is at your home, so why should it go through the company if it can do a local breakout and just simply go into the local network, and you can be printing right off your laptop without ever leaving your home network. Another thing is websites. That means if you're doing internet browsing, that internet traffic can go straight out of the AP, so we'll just do a local breakout, go into the internet, and never bother the corporate network on the other side. Now, what is also very important, if you would like to have something we call a unified infrastructure, that means instead of having two APs, one for your family and one for yourself, maybe you would like to have your family members or your guests using the same infrastructure because, it is RF tuned and all is good. Why not? Then you can establish something, or you can set something up we call a bridged mode SSID. And the bridge mode SSID or bridge mode interface means that whatever data enters that interface or enters that SSID will only and only do a local breakout. That means there is not even a route, and there is a firewall policy blocking communication between the internal and between the external network. That means if someone is accessing the bridge mode SSID, there is no way for the data or no way for, let's say, an attacker to get access to your corporate network. So even though it is the same infrastructure, even though we're talking about the same radios, it is from a security perspective absolutely safe, and there is no way how someone would, create a backdoor, or how someone could maybe attack the network from the outer world. So family members are good to use it. Then you have one unified infrastructure. Now, the key takeaways here are actually, first of all, that it's pretty simple. As you can see, you just simply plug it in and you wait for something to happen. You wait for the authentication to happen, for the tunnels to get established, and that's it. So it is actually the same way as you would treat an AP in your office. You just simply flip open your laptop, you have the SSID, you see the same SSID, the same level of security, same level of encryption. You probably get the same IP address even. You see the broadcast, the multicast being forwarded to you. So you have native access. So your laptop, for example, won't actually be able to tell whether you're sitting behind your desk in your home office or if you're back in your office. From a network perspective, it is exactly the same environment. Now, what is also very important, there's absolutely no need for any additional VPN clients to be installed anywhere because it is native. So there's no hassle with compatibility. There's no hassle with system updates. There's no hassle with virtual interfaces sometimes not working and stuff like that. So it is really native. It is just an SSID you connect to, the usual way for mobile phones, the usual way for tablets, for PCs, for laptops. So even from a management perspective, there is no change, because you have clients connecting to an AP, and it doesn't matter where the AP physically is located, because it just simply belongs to the family of our APs, and you see it as another AP. You see the clients, you see their tunnels, you see their data, you see their authentication, and you're in control. So even if we're building a greenfield, or even if we're not building a greenfield and we're just adding new APs to your existing network, it does not pose any load or any additional load onto the administrators, because you simply continue doing the same things you were doing before. You just simply add yet another AP and everything remains the same. If you already know how Aruba works, you know that our configurations typically sit in a template, and we call these templates AP groups. Should you already have a Wi-Fi network up and running in your office, you probably have one of these AP groups. So what you can do is very simply, as a new remote access point comes along, you can just simply put it into one of these already existing groups. So even from a configuration perspective, it will be just 2 clicks and that's it. And the configuration will be cloned onto this new remote access point without you even having to worry about, if it's going to be working, if, the security is going to be fine, if all the SSID parameters are configured correctly and stuff like that. I mean, all the features will be up and running without any issues. Now, a very frequently asked question is redundancy. How does redundancy work in this way or in this solution? Well, first of all, when it gets to connectivity, I already mentioned that we do have the USB interfaces. Pretty much all of our APs feature a USB interface. So you can always have an LTE or 3G modem sitting there in that USB using carrier data. And then, of course, together with your home data, DSL, FTTH, whatever you might have, it actually creates a connection redundancy. Now, should you have 2 data centers, you can always have one active tunnel to data center number 1 to its mobility controller, and you can have a backup tunnel to data center number 2. Should the active tunnel fail, the backup tunnel will get established and the data will start flowing to data center number 2. Yes, the secondary tunnel is down, so we'll need some time for this tunnel to actually get established, typically not longer than 5 seconds. Let's say worst case 10 seconds, so there would be a 10-second blackout after which everything would work or everything would be just simply tunneled to data center number 2. So that will be fine. If you have a geographical cluster, or maybe if you have 2 controllers in a single data center, you can have another scenario where you have one active tunnel to the first controller, and then you have a backup IPsec tunnel, which is pre-established. That means if you're talking to a cluster of 2 controllers, you can have a pre-established backup IPsec tunnel, meaning that if something happens to the primary one, it's only a question of routing, which typically takes about 1 or 2 seconds to complete. So the blackout period is even shorter. And should these 2 fail, you still have the tertiary or the third backup tunnel, if you will, which will need to get established. But you can lose, in this scenario, you could lose up to 3 controllers at the same time or simultaneously, and the connectivity would still be up and running. Now, one of the things pretty frequently people ask is, what about deployment? Like, how do we deploy it, or what kind of possibilities do we have? Well, first of all, we have the possibility to have something we call the Campus Connected AP, and we can actually make the Campus Connected AP to be a remote access point. That means we can pre-stage it. We can provision it while sitting in the office. We can simply make sure that it will be configured to the controller, then we just hand it out, and that's it. And the only thing it remembers is the host name or the IP address of the controller, so it will always find the way back home. Or if it is a remote access point, or if it is an instant access point, we can use something we call zero-touch provisioning. And for this, we have a service that is called Aruba Activate. Now, Aruba Activate is a free-of-charge service, which is delivered by means of a cloud-based pointer. So it is not the actual configuration in the cloud. It is just a pointer telling the AP what the initial config will be. So imagine you have a new IP coming up somewhere. It will check into the cloud service. It will check into Aruba Activate, and Aruba Activate will tell it what to do. And then, of course, what you can do in Aruba Activate is you just simply go into Aruba Activate. It looks something like this. And for each and every AP, you just simply say what will need to be done. So in this case, for example, in this example here, we are converting an instant AP to be a remote access point. That means to actually listen to a mobility controller. You see the AP group wrap-home, which is the configuration template name where the configuration for that particular AP sits. And you see the 10.2.70.100 IP address of the controller to which this instant AP should get connected to, and then of course, get provisioned. So this is as easy as it could be from Aruba Activate, and this happens automatically. This can be added to any existing installation or can be ordered while ordering new APs. And as I said, it's a free-of-charge service, which is all cloud-based, and it is only the pointer. It is not your configuration. Of course, what you can also do is you can have an instant AP remaining an instant AP and just simply building up VPN tunnels to a physical controller. And this can also be centralized or centrally driven by using Aruba Central, which is our cloud-based management solution. And to this these APs also can be pointed by Activate. So Activate can really ensure zero touch, so you will not need to go on site, you will not need to pre-stage anything, you will not need to work things out before APs will get delivered to their users. So this can happen automatically. However, should you not have Activate, and should you like to, let's say, migrate your instant AP to be or convert your instant AP to be a remote access point managed by a mobility controller, this can be very easily done using the web UI. So you just simply log into your instant AP, you just simply go to maintenance, you can convert it, and you just pick the action remote APs managed by a mobility controller. You punch in the host name or IP address of the mobility controller itself. It will get connected to that mobility controller, it will convert, and it will become a remote access point. However, should you be keen on having a VPN tunnel only and remaining, or let's say leaving the instant AP to remain an instant AP and not to be converted into a remote access point, that means fall into 100% jurisdiction of that mobility controller, you can go ahead and just simply establish a VPN tunnel instead. This is something we call IAP VPN, and what it means is you have your instant AP, that means you have your AP with its own built-in virtual controller, which is not dependent on any other hardware anywhere. And what you just simply do here is you configure a tunnel. You can configure a primary and a backup tunnel to 2 different controllers and tunnel your data to those controllers. That means you yet again get native access to your corporate network without having to have any VPN clients installed on individual connecting clients to this AP. So it is pretty much the same solution, but the logic still remains. I mean, you still have the instant access point. Now, another question is, as I said before, there can be devices with some, let's call them connectivity issues. So sometimes when I talk about these things, you know, when I talk about remote access points and when I talk about instant APs, people typically understand Wi-Fi. So typically it's all about Wi-Fi and Wi-Fi and Wi-Fi. And then someone might actually say that, what if my home office computer looks something like this? Well, then we might have a little problem. Why? It's not because it's dirty, it's not because it's old, but it typically features something like this. Yes, it's an Ethernet port. So what if I have a computer at home that features an RJ45 interface? That means it only has wired connectivity, and I only have a remote access point. Let's say I have the AP 303, but not the H version with those additional interfaces, but I only have one AP having 2 radios built in and no additional Ethernets I could use to actually hook this PC up to my network. What do I do? Well, in this case, no worries. I won't say bad luck. I will say good luck, because what we can do here is typically when your ISP gives you a modem, it typically comes with a little router, and that router typically features not 1, not 2, but sometimes even 3 or sometimes even 4 additional Ethernets. So what you can do here is you just simply plug this PC into any interface you see on your ISP router you have at home, or any internet, let's say, coming through wire. And what you can do is you can connect to your mobility controller. So you just simply go to the host name of your mobility controller /via, and what will happen is you will be presented with a captive portal. And on this captive portal, you will lock yourself in. That means you will probably use the same credentials as you do for, let's say, logging into the systems in your company. So, for example, this can be hooked up to a user repository. It can be hooked up to your Windows Active Directory. But in the end of the day, what is very important, you will get a package. You will receive something we call the VIA client, or Virtual Intranet Access Client. And what is very important, this client comes pre-configured. So you receive an MSI package or a DMG package, depending on the platform you're using, and it will automatically install. It will automatically install a virtual interface. It will automatically install and deploy the identity. It will deploy the connection profiles. It will deploy pretty much everything you need for your VPN dial-up to function. The only thing you will need to additionally do is you will need to log again in to the client, because it's going to be running yet again a user authentication or machine authentication, depending on the configuration, of course. But in most of the cases, it will be yet again your Windows Active Directory login. And what will happen is it will automatically establish that connection. It will also assess the network where it is connecting to. So you see that little pictogram of that log saying untrusted network. So it will detect the network, whether it is considered to be trusted or untrusted. And if it is untrusted, meaning that it is outside of your corporate environment and you cannot easily reach your resources, it will block all the connections, so it will prevent data leakage. It will establish that VPN tunnel, and only after that had happened, it will release all the connections. Now, what is very important here, we can work again in tunnel mode. That means we can tunnel everything back to the controller, or we can work in split tunnel mode. That means partially some data will go to the headquarters or some data will go to the corporate network through the tunnel, and some data can remain locally, do a local breakout and go into the internet, local printer, or whatever is necessary. We have all the Windows platforms or the Windows operating system. I mean, the entire family supported. We got Android support, iOS and macOS, and a couple of Linux distributions as well. And what is very important, you can not only have just simply a VPN tunnel established, but you can have some little logging as well. That means you can simply track if something goes wrong or something doesn't work correctly, what exactly is going on. That means these logs are being sent back to the controller so that the administrator sees them. And these are getting displayed for you as the user as well, so you can do some local troubleshooting as well. Plus, what is, I believe, even more important, next to the log tab, you see VPN profiles. So that means you can have several, and most of all, different VPN profiles installed in the same client. That means, for example, if you are dealing with a couple of customers, and these are individual customers, that means each and every one of them will have their own different connectivity and all different VPN requirements. You can actually have several profiles installed, so you don't have to you don't have to wipe or remove the profile if you want to connect from one AP or you want to connect from customer A to customer B, but just simply select a new profile and it will do a new connection. So you don't have to wipe what you have already created or what had been already downloaded. In the same way, this works in a Windows or Mac environment. It works in iOS or Android environment. It is exactly the same. When we're talking about mobile phones, you can download the VIA client of Google Play or Apple App Store, respectively. It will install, and then you just simply have to type in the URL of your home controller in your credentials, and you'll be good to go. So it, again, automatically configures and establishes the connection as desired by the security personnel. Now, last but not least, you probably remember there is a product in our portfolio called ClearPass Policy Manager. And for those of you who have already experienced let's say ClearPass Policy Manager or heard my presentation about ClearPass Policy Manager, you remember that the ClearPass Policy Manager, besides of being a very, very strong radius server or authenticating engine, let's say, there are several additional features or modules. And one of these modules is called ClearPass On Guard. And this ClearPass On Guard module, what it actually does, it runs client posture check. That means it actually checks the integrity and it checks whether the client obeys all the rules established by security personnel. That means, for example, there can be a rule saying that if you would like to connect, because it is pretty straightforward. I mean, when you are connecting your home PC, or when you are connecting, let's say, or when you allow your people, your employees to connect back to the network using their own privately owned equipment, you can never know whether this can be considered to be, in exclamation marks, healthy. Whether there is, let's say, a virus maybe, or whether there is some kind of discrepancy when it gets to firewalls, whether there are some applications running which are not supposed to be there, all these things. And if you would like to handle those, then you have to have some kind of posture check, making sure that you do not backdoor things. Because when you open up a VPN tunnel, you are actually opening a door, a huge door, into your network. And if you leave some kind of, compromised PCs into your network this way, then, at least one parameter is already gone. So you can never know. So it never hurts to double check. So what we can do here with OnGuard is we can actually have the OnGuard engine check on the integrity of your system. That means we can do this posture check and we check whether the firewall, which the requirement says it needs to be enabled, we can check whether it is enabled. We can check whether you have some kind of antivirus engine installed, whether the last system scan is not older than 1 week. We can scan whether, for example, the signatures of this antivirus engine are not outdated, whether, for example, there is no USB interface occupied by some kind of, or maybe there is no USB key or pen drive plugged in. Let's say that your hotfixes and Windows updates are installed, that no dodgy applications or peer-to-peer networks are running, etc., etc. I mean, I could be talking forever like this because we have about 40 different things you can choose from. But what is very important, we can configure the ClearPass On Guard engine in such a way that it would integrate into VIA. And this is what you would get. That means you would have the VIA client together with ClearPass On Guard. And what would happen is it would get in touch. You would download the VIA client of, this time not of the mobility controller, but of the ClearPass Policy Manager. And what would happen is you would just simply install it. It would get in touch with the ClearPass Policy Manager. It will run a posture check and check against all those rules configured in ClearPass, whether or not your device can be, or your host can be considered as healthy. If not, then you would get a clear text response. It wouldn't be an error code like minus 2667, and now please Google it yourself what it means. But it will really just give you a clear text response saying, you have to do this, you have to do that, or this does not seem to be right. We can even go ahead and do a auto remediation. So as long as the operating system will allow us to do that, we can go ahead and auto remediate your system. That means fix all the problems, so to say, or outstanding issues automatically, so you don't have to, and it will only inform you what we have done. But quintessence is that as soon as everything is fine and you meet all the security rules, only then the IPsec connection will get established. If something should happen afterwards, you will get disconnected, the posture check will run again, so we'll keep on scanning in the background, making sure that people do obey the security rules, not only at the time of establishing the connection, but throughout all the entire, let's say, duration of the connection. And when it gets to configuring everything from an administrator point of view, yet again, it is pretty simple because the only thing you really need to do in the ClearPass Policy Manager web UI, if you're already using, of course, On Guard, is you just simply flip the installer mode from On Guard dissolvable or permanent agent into something we call the VIA agent component. So when you enable the VIA component, you will see that for each and every operating system family, we do have now an MSI or exe package or a DMG file, which actually includes not only the On Guard engine doing the actual posture check, but also includes the VIA client that would establish that connectivity or that connection if the posture check runs smoothly and your host will be considered as healthy. Yeah, and I would say that pretty much concludes my today's presentation about remote access possibilities. I would like to thank you very much for spending the time with me today. If there are any questions, I'm more than happy to take them now or maybe later. You see my contact details here, so please don't hesitate to drop me an email. And since I believe we still have some time, yeah, we can deal with questions. So, so Christian, back to you, please. Thank you very much.
Thank you very much, Pavel. Acum, dacă aveți întrebări ori pentru mine, ori o să presupun că în mod special pentru Pavel, cu cel mai mare drag puteți să vă dați de pe mute și să-l întrebați. De asemenea, mai este un lucru pe care aș vrea să-l menționez înainte. Pentru această perioadă, Aruba a pornit o campanie astfel încât licențele pentru VIA și pentru Remote Access Point în varianta de evaluation sunt gratis pentru 90 de zile, astfel încât dacă există un client sau o oportunitate în care am putea să testăm aceste soluții, să arătăm exact cum funcționează, avem această posibilitate gratis timp de 90 de zile.